Okay guys, so in the previous two lessons we looked at compound interest and simple interest. What was similar about those two was that you just deposit some amount of money in the bank, therefore the principal remains the same. In this lesson we're looking at annuities. So annuity is a series of regular payments or withdrawals made at equal intervals of time. And in this lesson we're only looking at future annuities. So what you basically do in an annuity is that you either deposit or withdraw some money, but at regular intervals. So there are two types of annuity. In future annuity, you make some regular payments or deposits so that you have some lump sum at the end of that particular amount of time. So money is being put in. In present annuity, you take out some money so you have like no money left at the end. So an example of present annuity can be a loan. So you're basically making some payments so that your lump sum gets lesser and lesser. And an example for future annuity could be you're saving some money for your university or anything. Basically you're just saving up money in the bank by making some regular payments. Okay, so future annuity is when you deposit some amount after regular intervals of time, and a formula for this is A equals R, 1 plus I to the n minus 1 all over I. So A is the accumulated amount, that's the total amount that you would have at the end. R are the regular payments that you make. So suppose you're paying $200 every month or whatever, so that's your R. And I is the interest, and N is the number of compounding periods. And one thing to keep in mind is that interest should always be in decimals. Okay, and another thing is that the compounding interval must match the payment intervals. So if the interest is compounded monthly, the payments must be made monthly as well. Okay, so now we're gonna look at an example. Laura is planning to start saving for her pension by making regular deposits of $2,000 every 6 months after her 40th birthday. The plan she has chosen earns 5% per annum, compounded semi-annually. How much will Laura have on her 65th birthday? So an important thing to look at the question for is whether it's compound interest, simple interest, or an annuity. So an easy way to figure this out in this question is that it says regular deposits. It makes it really simple for us to know that it is an annuity. And now you have to figure out whether it's future or present. So we can when we read the question, we can tell that she's putting in some money. So that's pretty obvious that it's future annuity. So we know the formula is A equals R, 1 plus I, N minus N all over I. That's our formula. Now let's figure out what's given. Okay, so it says Laura is planning to start saving for her pension by making regular deposits of $2,000. So she's putting $2,000 every 6 months. So that means that $2,000 is the R. Now we have to let's see if we have I, and it says that she has chosen a plan that earns 5% per annum, compounded semi-annually. So we know that 5%, so we'll have to find out 5 divided by 100, which is 0.05. Sorry. 0.05 divided by 2 because it says semi-annually, so it it means it's 2 times in a year. So you divide it by 2 and you should get 0.025. Now let's see if you have n. It says that she decides. Okay, so now we have to figure out the n. It says it's 6 months, same thing as semi-annually, and she started at her 40th birthday till her 65th birthday. So all we have to do is simply subtract those two. We get 25 years. So we have to multiply 25 by 2. So it's 50 times in 25 years. Okay, so now we have R, I, and N. And they're asking us how much will Laura have on her 65th birthday. So how much money will she have at the end when everything has been done? So we're finding the accumulator amount. So all we have to do is now simply plug in everything in the formula. 2001 plus 0.025 to 50 minus 1 all over 0.025. Simply just plug in everything in your calculator. It's 1 plus 0.025 equals to the power of 50 minus 1 divided by 0.025 and multiplied by 2000. So the money that she's gonna have is 0.70. As we're dealing with money, make sure to round off your number to the nearest 10th decimal. So now we have our answer, so we can write our therefore statement. Therefore, Laura will have $194,968.70 on her 65th birthday. So for example, if you're not given the R value and you're actually given the A value, all you have to do is you can rearrange the formula. So it'd be R equals I times A 1 plus I to the n minus 1. You don't have to memorize this formula, but all I basically did is just rearrange this formula right here. So it's up to you guys, but it's an easier way to just find out the R in this case. So that's it for lesson 3, guys. Make sure to check out the review questions and good luck for the exams.